On May 23rd, 1967, the US Air Force almost started a war. It was during the most intense part of the Cold War. On that day, the American missile warning system, designed to detect threats coming from the Soviet Union, suddenly stopped working. Radar stations at all sites in the Northern Hemisphere seemed to be jammed. Officials of the US Air Force thought that the Soviet Union had attacked their radar and began to prepare for war. Then they realized it wasn't the Soviets, it was a solar storm. What are solar storms? How dangerous are they? And what can we do about them? That's what we'll talk about today. Before we talk about solar storms, I want to briefly thank our sponsor Magellan TV. Magellan TV is a streaming service for science and nature documentaries. They have more than 3,000 documentaries on science and science-related topics, and they're adding new ones each week. If you like this video, you may also like their documentary Set Course for the Heart of the Sun, which is about new satellite missions to the vicinity of the Sun and what we can learn from them. Magellan TV is super easy to use and runs on pretty much any device. If you want to try it out, use the link below, because that way you will get a full month free. Now let's talk about the solar storms. First things first, what is a solar storm? The Sun is so hot that in it electrons are not bound to atomic nuclei, but can move around freely. Physicists call this state a plasma. If electric charges move around in the plasma, that builds up magnetic fields, and the magnetic fields move more electric charges around, which increases the magnetic fields, and so on. That way, the Sun can build up enormous magnetic fields, powered by nuclear fusion. Sometimes these magnetic fields form arcs above the surface of the Sun, often in an area of sunspots. These arcs can rip and blast off, and then two things can happen. First, a lot of radiation is released suddenly. That's visible light, but also ultraviolet light and up into the X-ray range. This is called a solar flare. The radiation is usually accompanied by some fast-moving particles called solar particles. And second, in some cases the flare comes with a shock wave that blasts some of the plasma into space. This is called a coronal mass ejection, and it can be billions of tons of hot plasma. The solar flare, together with the coronal mass ejection, is called a solar storm. A solar storm can last from minutes to hours and can release more energy than the entire power we have spent in human history. The activity of the Sun has an 11-year cycle, and the worst solar storms often come in the years after the solar maximum. We're currently just starting a new cycle, and the next maximum of solar activity will be around 2025. The statistically most dangerous years of the solar cycle will come after that. Well, actually, the solar cycle is really 22 years, because after 11 years the magnetic field flips and the cycle isn't complete until it flips back. It's just that, for what the solar activity is concerned, 11 years is the relevant cycle. Yes. Thank you. How do these solar storms affect us? Space is big, and most of these solar storms don't go into our direction. If they do, the solar flare moves at the speed of light and takes about 8 minutes to reach us. The radiation exposure that comes with it is a health risk for astronauts and pilots, and it can affect satellites in orbit. For example, during a solar storm in 2003, the Japanese weather satellite Midori 2 was permanently damaged, and many other satellites automatically shut down because their navigation systems were not working. This solar storm became known as the 2003 Halloween storm because it happened in October. Down here on Earth, we are mostly shielded from the flare, but not so with the coronal mass ejection. It comes after the flare with a delay of 12 hours to 3 days, depending on the initial velocity, and it carries its own magnetic field. When it reaches Earth, that magnetic field connects with that of Earth. One effect of this is that the aurora becomes stronger, can be seen closer to the equator, and can even change color to become red. During the Halloween storm, it could be seen as far south as the Mediterranean and also in Texas and Florida. The aurora is pretty and mostly harmless, but the magnetic field causes a big problem. Because it changes so rapidly, it induces electric currents. The crust of Earth is not very conductive, but our electric grids are, by design, very conductive. This means that the magnetic field from the solar storm moves around a lot of currents in the electric grid, which can damage power plants and transformers and cause power outages. How big can solar storms get? The strength of solar storms is measured by the energy output in the solar flare. The smallest ones are called A-class and are near background levels, followed by B, C, M and X-class. This is a logarithmic scale, so each letter represents a tenfold increase in energy output. There's no more letters after X. Instead, one adds numbers after the X. X10, for example, is another tenfold increase after X. What's the biggest solar storm on record? It might have been the one from September 2nd, 1859. The solar flare on that day was observed coincidentally by the English astronomer Richard Carrington, which is why it's known today as the Carrington event. The coronal mass ejection after the flare traveled directly into direction Earth. At the time, there weren't many power grids that could have been damaged because electric lights wouldn't become common in cities for another 2 decades or so. But they did have a telegraph system. A telegrapher in Philadelphia received a severe electric shock when he was testing his equipment, and most of the devices stopped working because they couldn't cope with the current. But some telegraphers figured out that they could continue using their device if they unplugged it using just the current induced by the solar storm. The following exchange took place during the Carrington event between Portland and Boston.
Please cut off your battery entirely from the line for 15 minutes.
Will do so. It is now disconnected.
Mine is disconnected, and we are working with the auroral current. How do you receive my writing?
Better than with our batteries on. Current comes and goes gradually.
My current is very strong at times, and we can work better without the batteries, as the aurora seems to neutralize and augment our batteries alternately, making current too strong at times for our relay magnets. Suppose we work without batteries while we are affected by this trouble.
How strong was the Carrington event? We don't know, really. At the time, 2 measurement stations in England were keeping track of the magnetic field on Earth. But those devices worked by pushing an inked pen around on paper, and during the peak of the storm, that pen just ran off the page. It's been estimated by Karen Harvey to have had a total energy up of 10 to the 32 erg, which puts it roughly into the category X45. If you want to read more about the Carrington event, check out Stuart Clark's book, The Sun Kings. In 2013, the insurance market Lloyd's estimated that if a solar storm similar to the Carrington event took place today, it would cause damage to the electric grid between 0.6 and 2.6 trillion US dollars for the United States alone. That's about 20 times the damage of Hurricane Katrina. Power outages could last from a couple of weeks up to 2 years, because so many transformers would have to be replaced. The most powerful flare measured with modern methods was the 2003 Halloween storm. Again, it was so powerful that it overloaded the detectors. The sensors cut it out at
X17.
It was later estimated to have been
X35 plus minus 5.
So somewhat below the Carrington event. How bad can solar storms get? The magnetic field of our planet shields us from particles that come from the sun constantly, the so-called solar wind. It also prevents those solar particles from ripping the atmosphere of our planet. Mars, for example, once had an atmosphere, but since Mars has a weak magnetic field, its atmosphere was wiped away by solar wind. A solar storm that overwhelms the protection we have from our magnetic field could leave us exposed to the plasma raining down and could, in the worst case, strip apart some or all of our atmosphere. Can such strong solar storms happen? Well, I hope you're sitting, because for all I can tell, the answer is not obviously no. The more energy a solar storm has, the less likely it is. But occasionally, astrophysicists observe stars very similar to our Sun that have a solar flare so large they might put life in the habitable zone at risk. They don't presently know whether such an event is possible for our Sun or how likely it is. I didn't know that when I began working on this video. Sorry for the bad news. What can we do about it? Satellites in orbit can be shielded to some extent. Airplanes can be redirected to lower latitudes or altitudes to limit radiation exposure of pilots and passengers. We can interrupt part of the electric grid to prevent currents from moving around too easily. But besides that, the best we can do is prepare for what's to come, maybe stock up on toilet paper. How well these preparations work depends crucially on how far ahead we know a solar storm is headed into our direction. That's why scientists are currently working on solar weather forecasts that might give us a warning already before the flare. And about those megastorms, we don't currently have the technology to do anything about them. So I think the best we can do is to invest in science research and development so that one day we'll be able to protect ourselves. Thanks for watching. Don't forget to subscribe. See you next week.